This is lesson 25-1. It's on arcs and central angles, things that happen on a circle. I am sure that this first page of contextual situation is completely riveting and interesting, but due to time constraints, I am going to jump straight to the new vocabulary and start working some problems. So here's the vocabulary. We've got the word minor arc, it's right here, major arc, and central angle. So an arc is just simply a piece of the circle, and it's a minor arc as long as the piece of that circle is less than 180 degrees. And a major arc is when it is more than 180 degrees. So there are two different arcs in this picture right here. So that we can tell the difference between this piece of the circle that's between the points A and B, and the piece of the circle that's between the points A and B this way. Okay, so we've got this piece right here. Let me see if I think it's gonna, yeah, it's gonna redo the whole thing. Let me erase this real quick and do it again. I'm gonna do this, and I will change that color real quick. Well, I thought it would be quick. Make that blue. And then we've got this piece of the circle that's between the points A and B. So this one right here is the minor arc. And we only need we only need 2 points to name that. And we put a little curved line on top. That's the symbol for arc. So minor arc AB. If we want to talk about this major arc right here, we're still going to use the points A and B, because again, A is still where we started moving around the circle, B is where we stopped. But to make sure that you can tell the difference between a major arc and a minor arc, when it's a major arc, we use a third letter, and it just needs to be some other point that we pass through. So basically, and we still put the arc on top. So basically, this says we're traveling from A to B, but we have to pass through Q to get there. So here I'm just traveling from A to B, the shortest distance. Here I'm traveling from A around to B, but I have to pass through Q to get there. So this is a major arc. Okay, we have 2 radii. R-A-D-I is the plural for the word radius. Okay, so we have more than one radius, so we have radii. So when you have a radii that connect the 2 points that are the ends of an arc, then you form an angle right here. So that angle is called a central angle. And the central angle has the center of the circle as its vertex. So AOB. O is the center of the circle, and it's also the vertex of the angle. So when you have a central angle, the measure of the angle will equal the measure of the arc. And we measure arcs in degrees just like we do angles. Okay, so we've talked about a minor arc, we've talked about a major arc. We did not talk about semicircle. And a semicircle happens when, and I really wish I had a better circle than that, but a semicircle happens when we, the endpoints of the diameter are what form my arc. And just like a major arc, we have to have 3 letters to name it. Okay, so we would say semicircle. I don't know if y'all can hear my dogs chasing each other. Semicircle AQB. They're psycho. And of course, all semicircles are 180 degrees. Anytime a diameter cuts the circle, it cuts it into 2 semicircles. Okay, let's see what else we have on here. The notation for the measure of, if we're talking about the measurement, not just naming the physical thing, this is arc AB. This is the measure of arc AB. So the little letter M, the italicized M, goes in front when we're talking about the measure. So important information right here. So be sure you refer back to this page 350. I am working on, if we were in a face-to-face class, we would be doing a paper plate. We would take this paper plate and we would divide it into 10 pieces. And then as we go through and we learned about each one of these new words, we would add to this. So like, for example, in space number 1, we put the word arc, and there's 2 that we need to know, minor arc and major arc. I'm not finished with this. I probably need to put another point on here so I can name a major arc. But anyway, I'm working on this, and I hope to have it done by the time you are watching these videos. And I will have Mr. Moonion paste it on, or put a link to it on the web page. So it's because there's just so many things to remember about a circle. This is just a quick way to, study and glance at it and see if you remember what it is. So I'm doing my best to make this for you. Okay, so back to where we were. Let's work a few problems. So it says that here's circle C. We have 2 diameters, JR and KQ, and the measure of angle RCQ is 50 degrees. Okay, that is 50 degrees. I'm going to blow this up just a little bit. Okay, so if that's 50 degrees, then this arc, the arc is also 50 degrees. 50 doesn't look like a 50. The measure of this angle, central angle, is also 50 degrees because, yes, these are still vertical angles. So the measure of this arc is 50 degrees because any arc that's called the intercepted arc for a central angle, the angle and the arc have the same measure. Okay, so I'm going to say that again. This is the intercepted arc for that central angle. And the central angle and its intercepted arc, you see the word right there, intercepted arc. A central angle and its intercepted arc is the same. And these are all degrees. So the measure of arc, RQ, is 50 degrees. My 5 looked so much better, and then it rounded off. JQ, okay? Well, you may be thinking, well, we don't know anything about JQ. Remember, JR is a diameter, okay? So that means that this piece right here is a semicircle. So that means that whole piece right there is 180 degrees. So if this much of it is 50 and the whole thing is 180 degrees, then this piece right here must be 180 minus 50. So JQ, the measure of arc JQ, is 130 degrees. The measure of angle CRQ, the measure of CRQ. So they're drawing a chord in there. They're drawing a chord in there. Now, this is a very tricky question because we now have a triangle, okay? And we need you know what kind of triangle it is. Because two of the legs of that triangle are made out of a radius. CR is a radius and CQ is a radius. And what do you know about the measure of all radii in a circle? That's exactly correct. They are the same measurement. So this is an isosceles triangle. And you learned about an isosceles triangle theorem. 50 right here is the vertex angle. Those two legs are the same, so these are the base angles. So we know that 180 minus 50 will leave me 130, and that 130 has got to be divided evenly. So we divide both sides by 2. 2 will go into 13 6 times, and that leaves me 12. That gives me a 10, so that's a 5. So that means this angle right here is 65, and this angle right here is 65. So they're both 65 degrees. So the measure of angle CRQ is 65 degrees. The measure of arc JQR, we've already talked about that. We said that was 180 degrees because JQR is the semicircle. And so the measure of arc JKQ, okay, now we're going to go from J to K and then all the way back around to Q. So we're doing the 180 degrees right here from J all the way around to R is a semicircle. That's 180 degrees. And then we're adding on that last 50. So it's 180 plus the 50. So 8 and 5 is 3. Carry the 1. So that looks like it's 230 degrees. And then the measure of arc JK, we've already written that down. That was 50 degrees. Okay, write a definition for congruent arcs. Congruent arcs are arcs that have the same measure. Arcs that have the same measure. I don't know if that's exactly what Springboard said, but that's what they are. Okay, so given circle C with these diameters, okay, and they tell me that PL is perpendicular to JR, so I'm going to mark what that means. Have a 90-degree angle right there. And KQ bisects angle PCR. So that means that angle 1 and angle 2 are the same size. Explain why arc PQ why PQ is congruent to QR. The angles are congruent, so the arcs are congruent. Arcs of congruent angles, and we should be congruent central angles, will be congruent. Because if this is 45 degrees and this is 45 degrees, and I believe it is because it says that it bisects it. So this angle over here is 90 degrees. So this angle right here is 90 degrees. And if we cut it in half, then both of those angles are 45 degrees. Okay, and a central angle and its arc have the same measurement. So if that one's 45 degrees, then that one's going to be 45 degrees. Arcs, and it should be the word intercepted arcs. intercepted arcs of congruent central angles will be congruent. Okay, the measure of angle 1 plus the measure of angle 2, that equals 90 degrees. The measure of arc JP right here, we know JP is 90. So the measure of JP and PQ. So 90 plus 45, that's 135 degrees. Please justify your reasoning. Well, angle addition postulate allows me to add these two angles together because they're adjacent to each other. So 90 degrees plus 45 degrees will give me an angle JCQ. That's 135. The intercepted arc of angle JCQ is 135. You can add arcs together just like you can add angles. Okay, I'm going to make this smaller so we can maybe see the picture at the same time that we're trying to work the problem. JQ, the measure of arc JQ is 135 degrees. That's what the same thing that we just answered right here, JP plus PQ. The measure of arc JRQ. So I'm going to go from J all the way around, all the way to Q. So this piece right here is 180 plus 45 more. So 180 plus 45 more will give me 225 degrees. The measure of arc JL. Well, this is that 90-degree angle again. Okay, if those two are perpendicular, then JL, the angle JCL is 90 degrees, so that means arc JL is 90 degrees. And the measure of JRL, I'm going to redraw that because that's a triangle. JRL. Okay, so this is J, this is R, and this is L. Okay, so we need the measure of this angle right here. Okay, I know what it is, but I know something that y'all don't know. So I'm gonna have to figure out. Oh, no, shoot. JRL. Okay, so we have I don't know how you're supposed to work that one because we haven't learned about the kind of angle that JRL is. So I'm sure I'm missing something because I don't think they would ask you to do something that you couldn't do. So if you can figure out what it is, go ahead. I'm going to go ahead and stop the video because I don't want to waste all of the time that we spent working on these other problems. But I think the only thing left to do, that's what I thought, is check your understanding and your lesson practice. So I'll come back with the answers to these problems, and I will include the answer to that problem. Like I said, I can tell you right now, I know what the answer is. It's going to be, oh, no, again, oh, yes, I can. Yes, we can. I figured it out. So ignore the whole thing, and let's look at CRL. That's what was throwing me off, that they wanted me to go all the way to J. Well, I can still make the triangle because CRL, angle R right here, is the same angle as if it's JRL. So just ignore that part. And what do you know about this leg and what do you know about this leg? Those are each a radius, and we know something, so that means they're the same size. We know that this angle right here is 90. So if that angle right there is 90, what do these two have to be? You take 180, take the 90 away, and you get 90. You take that 90 and you divide it into 2 equal pieces, and you get 45. So angle JRL is 45 degrees. And my reason is that CRL is one of the base angles of a right isosceles triangle. So that would be my explanation. Now, we are going to learn, this is probably a setup for one of the things that you're going to learn probably in the next lesson. So anyway, stop the video and work to check your understanding in the lesson practice, and I will make my next video that shows you what the answers are.